Hello friends, I welcome you in the video lecture on design of pressure vessel part 4. So in this lecture I am going to cover the next problem of type 1. So this is an important point required for type 1 numerical. So one pressure vessel is shown in this picture, that is a cylindrical pressure vessel. So this is a cylinder having some internal diameter and it has two closed ends, and this is a hemispherical closed end on both the sides. So we are going to see in this lecture if volume of this pressure vessel having cylindrical shell and having hemispherical enclosure, if it is given, then how to write the equation of volume of this total pressure vessel, the internal volume of this pressure vessel with cylindrical shell and hemispherical enclosure. So this is the length of this cylindrical shell and having internal diameter di. So in numericals, sometimes the storage capacity of cylindrical pressure vessel with hemispherical enclosure in meter cube will be given. This storage capacity indicates the total internal volume of this pressure vessel. If it is given, then we can write the equation: the total volume of pressure vessel is equal to volume of cylinder. So this is the volume of cylinder, which is shown by this color, plus twice into volume of each hemispherical end. So this is first hemispherical end and this is the second hemispherical end. So the total volume of hemispherical end is twice into volume of single hemispherical end. So it gives the volume of cylinder plus 2 into volume of hemispherical end. It gives the total volume of pressure vessel. So we can write the total volume V is equal to volume of cylinder is equal to pi by 4 di square into L, where di is the internal diameter of the cylinder and L is the length of cylinder, plus twice into pi upon 12 into di cube. This pi upon 12 into di cube is the volume of single hemispherical end. So this is the single hemispherical end and its volume is pi upon 12 into di cube. As there are two hemispherical ends on left and right side, so we have to multiply by 2. So this equation gives the total volume of pressure vessel with cylindrical shell and with two hemispherical ends. So if this storage capacity in meter cube will be given in the numerical, then we have to use this equation to find out the di, that is internal diameter. So let us solve problem based on this type. An air receiver consists of a cylinder having length twice its inside diameter. It is closed by the hemispherical enclosure. It has a storage capacity of 0.30 meter cube and inside pressure of 5 megapascal. The material used is plain carbon steel with SUT equal to 360 Newton per mm square. Use a factor of safety of design as 4. Determine the thickness of cylinder and hemispherical enclosures, considering the joint efficiency of 85%. So with this problem statement, let us write the given data first. So the type of shell is given cylindrical shell. Then the length of the cylinder is equal to twice its inside diameter. So we can write small l is equal to twice into di. Then it is closed by hemispherical enclosure. So type of enclosure is hemispherical enclosure. Then it has a storage capacity of 0.30 meter cube. So storage capacity is 0.30 meter cube, which indicates the total inside volume of this pressure vessel. Then inside pressure is 5 megapascal, that is operating pressure 5 megapascal or 5 Newton per mm square. The material used is plain carbon steel. SUT is equal to 360 Newton per mm square. So therefore, now we will calculate first design pressure based on this inside operating pressure. So we know that design pressure Pi is equal to 1.05 into operating inside pressure. Operating inside pressure is 5 Newton per mm square. So let us put this value here and calculate the design pressure Pi. Now next we'll write here the value of this SUT, then factor of safety FS4, and we will calculate the allowable tensile stress sigma T. So it is given by SUT upon Fs. So SUT value is 360 and Fs is 4. So answer of allowable tensile stress sigma T is 90 Newton per mm square. Now next, the efficiency of weld joint is given. So eta is 0.85. So with this given data, we have to find out two parameters. First is thickness of cylindrical shell, and second, thickness of hemispherical end closure. So we have to find out this two thickness. So let us solve this problem. So first, thickness of cylindrical shell. We have to find out this thickness of cylindrical shell. So we know that the thickness of cylindrical shell is given by equation TCS is equal to Pi di upon twice sigma T eta minus Pi plus Ca. Equation number 1. Now in this equation, first we don't know value of di, and second we don't know value of corrosion allowance. We know sigma T, we know eta, and we know design pressure Pi. Now out of these two unknowns, that is di and Ca, first of all we'll assume corrosion allowance Ca is equal to 1.5 mm as we have discussed in the previous video lecture. Now to find out di, we have to use the equation of total volume of pressure vessel. That is, we have to use this storage capacity. So as we have seen in the beginning of this lecture, this total volume is equal to pi by 4 di square into L plus twice into pi upon 12 into di cube. Here we have to put this L is equal to 2 di. So by putting L is equal to 2 di and total volume, that is storage capacity, as 0.30 meter cube. Here now on the RHS there is only one unknown, that is di. So calculating this will get the di, that is 0.523 meter. As the storage capacity is in meter, so we'll get this di in meter, but we need it in mm, so multiply by 1000, so we'll get the answer of di as 523 mm. Now we know Ca and we know di, so let us put these values in equation number 1. So we can put this all the values here and we'll calculate the value of thickness of cylindrical shell, that is TCS. So its answer would be 20.08 mm. Now let us solve the second point, thickness of hemispherical end closure. So thickness of hemispherical end closure is equal to question mark. We know the thickness of hemispherical end closure is given by equation. So small t is equal to Pi Ri upon twice sigma T eta minus 0.2 Pi plus Ca. Now here this Ri is nothing but the inside radius of hemispherical enclosure, and it is half of inside diameter of cylinder, that is half of this di. Just we have calculated the di, so Ri is equal to di upon 2. So di is 523 upon 2 is equal to 261.5. Now put this Ri here. Remaining parameters are already known to us, so by putting all these values we'll get the answer of thickness of hemispherical enclosure as 11.03 mm. So this is the second and last answer of this problem number 1. So with this answer, our first problem is completed. Now let us solve the second problem. A spherical shell of internal diameter of 2 meters is subjected to an operating pressure of 1 Newton per mm square. The allowable tensile strength of plate material is 150 Newton per mm square and corrosion allowance is 2 mm. The weld joint efficiency is 85%. Determine the thickness of spherical shell. So let us first of all write down the given data. So first write down the spherical shell. It is not a cylindrical shell, it is a spherical shell. So write down spherical shell. The internal diameter di is 2 meters. So convert it into mm. Next, operating pressure is given 1 Newton per mm square. Immediately calculate design pressure. So design pressure is equal to 1.05 into operating pressure. So put the value of operating pressure here and calculate design pressure Pi. So value of design pressure Pi is 1.05 Newton per mm square. Allowable tensile stress is given. Allowable tensile strength, so sigma T is given. So sigma T is the allowable tensile strength. It is directly given. So sigma T is equal to 150 Newton per mm square. Corrosion allowance Ca is given 2 mm. The weld joint efficiency eta is given 85%. So its value is 0.85. And we have to determine the thickness of spherical shell. So we'll start the solution. So first point is the thickness of spherical shell is equal to question mark. We know the thickness of spherical shell is given by equation TSS is equal to T suffix SS. Spherical shell is equal to Pi di upon 4 sigma T eta minus Pi plus Ca. Now here all the values are known. Pi design pressure 1.05, internal diameter di it is 2000 mm. Allowable tensile stress, it is also given directly 150 Newton per mm square. Weld joint efficiency, it is 0.85. Again, it is a design pressure, and corrosion allowance Ca, it is also given 2 mm. So by putting all these values here, we'll get the answer of thickness of spherical shell as 6.126 mm. And this is the answer of this second problem. So with this answer, we have completed the solution of second problem. So thanks for watching this video. If you have any query related to this type 1 problems, numericals, you can ask in the comment section. Thank you very much.